Hey guys, so let's start going over other laws in our module 7, right? So we just went over the ideal gas law, so let's go over the smaller laws, I guess, where things are actually constant. So Boyle's law, we know, is going to deal with PV. So I forgot to erase these. So yeah, Boyle's law is going to be dealing with pressure and volume. So whenever we look at our ideal gas law, so let's look at that. We're going to say PV equals nRT. Whenever we're dealing with Boyle's law, what we're assuming is that moles are constant and temperature are all constant. They are not changing. So that's what Boyle's law is saying. Boyle's law is saying that everything else is constant and our only variables are pressure and volume. So let's keep that in mind. So now that we see that those things are constant, we're going to make sure that everything is on the left side of the equal sign. So this is going to be PV, which is exactly what we want, right? But we're looking at a relationship, so we're going to say PV is equal to PV. So in case you guys didn't know how to derive that equation, you can do it that way, and you can see that this is P1 V1 is equal to P2 V2. So that's how you can kind of derive the equation in case you forget it during the exam. So the last thing you want to know about Boyle's law is that pressure and volume are inversely related, which means that as I increase my pressure, I will decrease my volume. And as I decrease my pressure, I will increase my volume. So it's going to be the opposite. One is going to have the opposite effect on the other. So okay, let's look at Charles' law. In Charles' law, we're going to be dealing with temperature and volume. And I like to say Charles watches TV. That kind of helps me remember this. Okay, so now let's look at the ideal gas equation again. So we're going to say PV equals nRT. So I'm going to say, okay, well, in Charles' law, that means that, in Charles' law, that means that pressure is constant, our moles are constant, and our constant is constant, right? And then make sure that you get them both on the equal side again, on the same side of the equal sign again. So I'm going to say, okay, V over T is equal to V over T, right? Because it's a relationship. So I'm going to say, okay, V1 over T1 is equal to V2 over T2. And that's going to be Charles' law. And then the last thing you need to know for Charles' law, I'll do it back in purple, you have an increase of volume is going to increase your temperature. So you're going to have a direct relationship in this case. So in other words, as you decrease your volume, you would also decrease your temperature. So they're going to be the exact same effect on each other. And then looking at Lussacs law, we're going to be dealing with pressure and temperature. So let's go back to the ideal gas equation, PV equals nRT, and then let's start canceling things out. So we're going to say, okay, well, that would mean volume is constant, moles are constant, and our constant is constant, right? So we want to get them both on the left side of the equal sign, so we're going to say P over T, is equal to P over T. So, of course, what does that mean? That means our equation is P1 over T1 is equal to P2 over T2. And then we're going to look at the relationship and we're going to say, okay, well, these are directly related again. As I increase my pressure, I will increase, I wrote it the other way. I would increase my temperature, right? And then as I decrease my pressure, I would decrease my temperature. So that's how you can kind of see the relationships between those. Make sure you get them on the left side of the equation, and then it'll kind of tell you how they're related. Are they inversely related or directly related? So the last law that we have is the combined gas law, which the combined gas law is going to deal with pressure, volume, and temperature. So if we look back at the ideal gas law, that would mean the only things that are constant are moles and are constant, right? So of course, I want to get them all on the left side of the equal sign, so I'm going to say PV over T. So what does that mean for our equation? So that would be P1 V1 is equal to, over T1 is equal to P2 V2 over T2. So this is kind of helpful to kind of figure out what these equations are. And then just know that combined gas law, we're not exactly going to deal with the relationship between all of them. We're just going to kind of look at the fact that it's P1 V1 over T1 is equal to P2 V2 over T2. And then just keep in mind that any time we would cross out things like here or here, where we were crossing out, that's because those things are constant. The only ones changing is pressure, volume, and temperature here. And then if you go to the Lussacs law, pressure, and temperature are the only ones changing. So it's kind of like that's how all of them go for each one. This is like a simple video just to show you how to derive the equations and look at the relationship between pressure, volume, and temperature. So I'll see you guys in the next video for Module 7.